primary reason for having a control group and a treatment group in a clinical study is, well, let's see if we understand what's being said here. The answer to this question is to eliminate confounding variables. So what are we talking about, confounding variables? Well, in a clinical study, that's another word for an experiment. A clinical study is an experiment, and what that means is you have two groups, a control group and a treatment group. Remember the Boy Scouts example. One of the other problems talked about the Boy Scouts and how states with more Boy Scouts also have more criminals 10 years later. But that doesn't mean Boy Scouts are causing people to become criminals. These two things are just associated. Oops. These two things are just associated. It's not causing it, right? And what was causing states to have more Boy Scouts and more criminals? Population. Higher population states have more everything, more criminals, more honest people, more tall people, short people, Boy Scouts, Girl Scouts, non-Boy Scouts, etc. Higher population. So population is what we call the confounding variable. It confounds it. It makes it tricks us, because population is kind of a hiding variable among states, right? California, which has more population, has more Boy Scouts and more criminals. Vermont, which has a smaller population, has less Boy Scouts and less criminals. It doesn't mean Boy Scouts are causing criminals. Just because states with more Boy Scouts also have more criminals 10 years later doesn't mean Boy Scouts are producing criminals. It's not causation like that, because population is a confounding variable. That's what tricks us. Population, states with higher populations have more of everything. So it makes it look like Boy Scouts are causing criminals. It confounds us. It tricks us. Population is a confounding variable. Well, how do you get around that problem? Well, that's why you have a treatment group and a control group, to eliminate confounding variables. You see how this works? If you have a drug and you're wondering if the drug works, what you do is you have a treatment group that gets the treatment, they get the drug, and a control group, they get no drug. They don't get it. So you give it to one group and not to the other, and then you see if there's different results. If the results come out different, then you know the treatment is making the difference, because that's the only thing different in those two groups, right? You take like 100 people, and at random you put 50 in the control group and 50 in the treatment group, at random. And that way, those are just randomized people. There's nothing else unique about it. You can't put like all the men in one group and all the women in the other, or all the tall people in one group and all the short people in the other, or all the whatever. You have to just do it totally random, so that these 50 people and these 50 people have everything else just mixed up random. The only difference between these groups is one group gets the drug, the other group doesn't get the drug. So if we see later that there's a different outcome, the only difference between these groups is who got the drug and who didn't. Otherwise, they're just 50 random people, 50 random people. So if something comes out different among them, it must be the difference of the drug. That's how we know the drug is causing the difference. That's why we have a treatment group and a control group. That's why we do an experiment, a clinical study, with two separate groups of random people that have no other major differences, except one group gets the drug, one group doesn't. The control group doesn't. So if there's a different outcome, we know the drug is causing that. Whereas if we just look at states and Boy Scouts and criminals, that's just observing. We didn't cause anything to happen there. You cannot determine causation. It's not causing. The only way you can determine causation, the only way you can get rid of the confounding variable, is having a treatment group and a control group.